All right, here's some additional examples just if you feel like you want a little bit more practice here with the logarithms. So let's look at expanding something that looks like this. So log of 1,000 divided by the quantity of x squared plus 1. So I see that I have a big old division bar right here, so that tells me I'm going to be subtracting what I have. So it's going to be log of 1,000 minus log of that entire denominator. Now, a couple of common things right here is not recognizing that log of 1,000 could be simplified. Remember, this is secretly base 10, so 10 to what power is 1,000? Well, 10 to the third power is 1,000. And then minus log of the quantity of x squared plus 1. I can't do a darn thing with this. It has an addition sign inside of it. The x squared and the 1 are not being multiplied, they're not being divided. So that means I don't have any properties that break up something with addition. So this is just going to be left as is. So that's a very common mistake if I can't do anything. And also think about it, x squared plus 1 doesn't factor. So I can't break it up into like two different products that way either. So it is just that entire quantity that I'm going to be having. So this would be my final simplified expanded version. Maybe something like this. Seeing that square root in there sometimes throws people for a loop. So let's see here. I've got the big old division bar going on, so I know I'm going to be subtracting that denominator. So I'm going to just start with the natural log of the square root of x, and then I'm going to have minus the natural log. I'll keep it like this for right now, natural log of y times z, but I think this might actually make it a little bit more complicated, and I'll show you how I think about it, kind of like with a round 2 with the same problem. So natural log of square root of x is equivalent to x to the 1/2 power. And maybe I'll just kind of focus on this side right here for right now. So I'm going to go ahead and use my power property and move that 1/2 out front. So that piece of this is finalized. It's 1/2 times the natural log of x. Now, keeping in mind with this second piece, I am subtracting the natural log of y times z. So think about keeping that subtraction sign in there. I have the natural log of, well, if I have y times z with my arguments, this is going to be natural log of y plus natural log of z here. But I have that subtraction sign. I need to make sure I distribute that subtraction sign to everybody inside the parentheses. So I'm a big fan of adding the opposite when I'm subtracting an entire quantity. So this means minus natural log of y minus natural log of z. So this would be expanded. Again, expanded means breaking up as much as you can and writing it with as many logarithms as you can. The alternative way to kind of think about this is I'm still going to end up through the same process with 1/2 times the natural log of x, but when I see I have y and z both in the denominator, that tells me I have to be subtracting both of those. So minus the natural log of y minus the natural log of z. Because again, if I were to work backwards from this point right here, that y would need to end up in the denominator, so that means it needs to be subtracted, and that z needs to end up in the denominator. So again, it would have to be subtracted. All right, go ahead, pause the video here, try these two. I'm trying to be kind of tricky with them. Try them, and then we'll go through and we'll talk about them together. All right, hopefully you had a chance to look at these. So let's take a look at the first one. If I notice 7xy is all being taken the square root, I can rewrite that as 7xy all raised to the 1/2 power. Now, if I see that 1/2 out there, I can go ahead and use my property and drop that out front. So this would be 1/2 log base 4 of 7xy. Now, the thing to remember here is this 1/2 needs to get applied to the 7, the x, and the y. So kind of keep that in mind. You might want to even put your like a grouping symbol around it to make sure that 1/2 is getting distributed to everybody. So let's look at this. So this would be 1/2, and then this would be log base 4 of 7. If the 7, x, and y are all being multiplied, I'm going to rewrite them with the same base, and I'm going to be adding all of these logs together. So it's going to look something like that. And then my last step would be to distribute the 1/2 to everybody. So 1/2 log base 4 of 7 plus 1/2 log base 4 of x plus 1/2 log base 4 of y. So that would be expanding that entire logarithmic expression. The second one, yeah, same idea here. Let's just kind of dive in. So we have natural log of x to the 10th power. That's in the numerator position, so that's going first. And then the y and the z are both in the denominator position, so that tells me I am going to be subtracting both of those. So minus natural log of y, and then minus again the natural log of z. And then the only thing it looks like I can do here is I can move that exponent out front. So 10 natural log of x minus the natural log of y minus the natural log of z. All right, let's just try two more here for condensing. So here's two I'm going to give you. Try to condense, simplify as much as possible, and see how it goes. All right, hopefully you had a chance to try these. Let's look at this first one. This one isn't terribly exciting, but I do see just numbers. I don't have any unknown values in here in the base or the argument. So it's always kind of worthwhile if you can maybe do something ahead of time. So do we know what power we could raise 12 to and end up with 8? I have no idea. Something small. What about 12 raised to what power is 18? I have no idea. So what that tells me is I can't do any kind of like initial simplifying. So let's see what happens when we work with our properties here. We are adding them. So this would clean up to be log base 12 of 8 times 18. Pretty sure that's 144. Now this actually turns into something that we know. 12 to what power is 144? Well, 12 to the second power is 144. All right, for the last additional example here, something like this. We are trying to condense this. The goal is just to write this using one log. So here we go. I see a whole bunch of stuff going on. Each one of these has a value out front that I'm going to go ahead and bring up as an exponent on these. So that'll be my first step. So natural log of m to the 4th power minus natural log of n to the 3rd power minus natural log of p to the 1/2 power. Okay, so next up is I'm just going to look at what signs I have. Both of these are being subtracted. So that tells me that the natural log of m to the 4th, so m to the 4th is going to be in the numerator of the argument. And then if I'm subtracting n to the 3rd, that goes down into the denominator. And I'm subtracting again p to the 1/2 power. That would also go in the denominator. So you could write it like we have it up here, or the only other thing that you could do would just be to replace the 1/2 exponent with the square root. Either should be just fine. So